Okay, I can start to take my session. Hello, everyone. Welcome to my today's session, which is DP100 designing and implementing a data science solution on Azure. So my name is Rahat Yasir. This is the last episode or the last session of this series, I believe. In like before that, I have taken another session on this series, which was on AI 102 or AI 100, AI engineering. And today's one is more like data science, DP100, that one. And at the beginning of the year, we have also like taken another session, AI 900. That was also like I saw like got a lot of views and everything. So just to help everyone, like all our audience, so the purpose of this session is to give the proper guidance. What are the things you guys need to learn or read so that you can quickly adapt and like get the certification and pass it. So if I talk a bit about today's agenda, like we'll talk about Azure AI or Azure AML, Azure Machine Learning tools, and what are the things that we have. For the data scientist, what are the roles and skills you will need? The prerequisite of DP100. There are like four categories in DP100. We'll talk about them in four different sections, and also like as like AI 100 and AI 900 like a session will give lots of like we'll do a lot of like practice of testing questions and answers. So I will expect from everyone that they will participate. You can like just speak what is the answer that you think, or you can just like type on the chat. I will monitor that one. So the purpose of this session is to be more interactive and to be honest, like unlike this DP100 is not like AI 100 or AI 900. AI 900 is one of the easiest. Then AI 100 is like not too complex, but DP100 I personally felt that is very comprehensive. You need to cover a lot of things as it is like like from the exam title, designing a data science solution. So you need to know a lot of like data science basics. You need to know Azure machine learning. You need to know the full tool, how to train model, compute data, like different kind of like deploying model monitoring, model drifting, all those things. And it is quite impossible to cover everything in an hour in one session of DP100. So the way I designed today's session is so we will cover all those like things from a high level point of view. What are the like components? What are the things you will have to learn in DP100? We'll cover it. We'll also like share all the resources that you will need, and we will ask all the questions as well, like a sample question, so that you get the idea what kind of questions you can expect from the exam. Okay, if I give a small overview of about myself and my journey, right now I'm working at like Isaac Instruments in Montreal, Canada, as the director of data science and AI. But in the past, it's been like more than 12 years I'm working in the data and AI industry in various like multinational organizations. Uh, by profession, I'm a software engineer. Then I learned I did my master's in AI, but I'm also a Microsoft MVP. It's been like 7 years that I'm a Microsoft MVP in AI. Okay, so before we jump into that like exam topic, I would just like I have already given showed this specific slide in AI 100, but I just want to like give a like a small overview before we jump in. So what happened in terms of like AI and ML life cycle? So and where the data scientist is, or data science like solution designer is. So this is kind of like the life cycle steps with all the key personas. So the way we see it is we have the business leadership, they set the goals. Data engineers, they collect, gather, and prepare the data for you. Then the data scientists, they work to develop the machine learning model, process the data, find out different kind of like data science related visual like patterns, like statistical analysis, and then they also develop the model. They work with machine learning engineers to productionalize that model to put it in production. ML engineers are the one who deploy the model. They implement work with the app developers to connect the model with the apps, web and mobile apps, and when it's deployed, the model is deployed by the ML engineers, connected by the app developers. Then data scientist works again for monitoring, for data drifting, to identify if there is any bias or not, all those things. So in our today's session, we will mostly talk about these sections, but we will also talk about a bit on the model deployment as well, which is a part of the overall curriculum. But as you can see, the data scientist is today we will talk about what kind of model they design, how to design the model, what are the things they need to do, what are the things they need to learn, what are the things they need to consider, those things. So if we just take a look at the overall number distribution on this exam, or what is expected, this is taken from the official Microsoft side, where designing and implementing a data science solution exam have four types of section. One is we need to manage Azure resources for machine learning. We need to run experiments and train models. We need to deploy and operationalize machine learning solutions, which is 35 to 40% of the marks, and implementable responsible machine learning models. So these four are the overall criteria, and we will also take a look at some sample questions, which is taken from the Microsoft official site. Before we jump into the actual machine learning, all the DP-100 specific content or Azure machine learning specific content, I would like to next 7 or 8 slide actually. So it's kind of give a overall a recap of machine learning, what is happening, how to do things and everything. So when we talk about machine learning and data science, that's what we see. So we hear about artificial intelligence, machine learning, deep learning, data science. So it's actually, some people think it's scattered, everything is everything. No, actually. So AI is actually the full big umbrella. Machine learning is a subdomain of AI, and deep learning is another subdomain of machine learning, where in machine learning we handpick the features. Deep learning is advanced enough to choose its own feature by itself, and data science is something that is overlapping in everywhere, where it's kind of like extracting the meaning of the data, finding different pattern from the data, getting values from the data, like a mix, matching the business value, finding different kind of necessary, useful, situation pattern, all those things. The designing model also falling under data science category as well. So within the data science, there are different kind of data as well. We deal with different kind of data. Sometimes they are tabular, sometimes they are structured data, sometimes they're unstructured data, sometimes they're numbers, sometimes there could be images, there could be anything. So based on the data category or type of the data, we choose different kind of machine learning model. I will recommend you to quickly take a look about those graphs or visualization. So there are three types of data category in data science. One is category 1 data, category 2 data, category 3 data. Category 1 data, which is text or number, which is most of the questions of this, actually all the questions of the DP100 exam will be related to category 1 data or text or number. So it's mostly tabular data, but there is a section in the DP100 exam where they talk about CNN, convolutional neural network, or deep learning model as well. But most of the questions you can expect to get text, number, or category 1 type data. So within the category 1 type data, there are four type of modeling that you will see, mostly three actually. In DP100 you won't see much in the recommendation, but the three types of machine learning model that you will see are classification model, regression model, and time series forecasting. These are the like top three. And there will be another one. There will be some questions on clustering. So like if you have some data and it's kind of like coordinates, values, or something, and it is not annotated, you cannot use supervised machine learning algorithm. In that case, you will use clustering algorithm, which is unsupervised machine learning algorithm. So in which is also like falling under category one, text or number based like category data. So in category one, there are like classification model, regression model. So what is regression model? So you have a lot of information, a lot of values or numbers. When you, based on those numbers, when you are predicting something, that is regression. So if I give an example, so you have weather. So this morning you woke up, you looked at your mobile phone and you saw the with like the predicted weather today is at 15 degrees Celsius, and there is no chances of rain. So predicted weather 15%, like 15 degrees Celsius. This 15 number is actually predicted by a regression model. So it takes all the information of last few years of weather data, and based on all those things, it is predicting today's weather prediction will be 15, a single digit. So when you are predicting a numerical value, it is a regression model. Then if there is a model where you're checking whether it's gonna rain or not today, yes or no. So this kind of like binary classification is classification model. So you are uploading the same type, all the data, but you are just training based on whether it will rain or not, zero or one. So this kind of visualization. Then if you also want to like, if you have information of your if you're a businessman, you have a business and you have all the sales information of last 10 months or 1 year or 2 years, but you, based on last 3 years of sales, you want to forecast what will be the sales of next quarter or next year, so that you can forecast the growth and do something. So that is actually time series forecasting. Whenever you are using the time as a timestamp, time interval, as a like feature or column, that will be considered as a time series, and you are predicting the numbers or values of this series, like next quarter, the quarter after, and then after, so like that. So you will get some questions regarding that time series as well. And in time series, like mostly Azure machine learning and Azure automated machine learning both have this time series feature. And the fourth one is recommendation. So what is recommendation model? So if you have any AI model, like, or suppose like when you do shopping at Amazon, you have done the shopping, you bought a like a blue t-shirt or something. So what AI model does, it kind of like make a relationship correlation with all the people who also bought this blue t-shirt, and right after that, what did they order or what did they bought. So some of them like bought also like a red bag or something like that. So you will start to get recommendation in your bottom bar. Hey, you should consider buying this like product as well. Why? Based on all the other users who has also bought this blue T-shirt, they ordered this red bag too. So this kind of like recommendation model. So these are the like top four machine learning categories, like criteria that you will face like in DP-100, and this is under the category one data. Then the second one is category two. So do, I don't expect you to get any question from category two, other than could be from like sentiment or like small something. But in our AI 900 or AI 100, we have talked about category two data, where it's more like sentiment analysis, identifying a conversation. Suppose when we talk to Google Home or Cortana or Apple Pod or something like that, Alexa. So we say, what is the weather tomorrow in Palo Alto? So it like takes different like small entities within this single sentence and prepare some kind of response. So you can see the intent is weather forecast when tomorrow, which is this date, place is Palo Alto, something like that. So same like from another sentence, it can also do sentiment analysis, identifying different key phrases, name entities, detecting language as well. Then the third one is image or video. You will get very small amount of questions, maybe one or two, regarding convolutional neural network, CNN-based image model training, how to do it in Azure machine learning, that kind. But you won't get much of it, like facial recognition or description or image classification. Those, yes, image classification very basic, like shape detection. If you upload three types of shapes, and you train a model, CNN model, that it is shape one, shape two, shape circle, shape square, shape triangle. So how to do it? So what are the things you will have on that convolutional like model? So those things. So, but image or video processing falls under category 3 data, and you can see all those like object detection, facial recognition, like image search, image classification, all of them falling under this category. So these are the like three types of like data category and the machine learning model that you will see in your exam. So before we jump in, right from here, as you get to know that what kind of like machine learning model you will get to learn, get to face. Now we will talk about more regarding Azure machine learning as a tool. So in this exam, DP100, you will get a lot of question from Azure machine learning, which is ml.azure.com. So from that one, what you can do, Azure Machine Learning Studio, what you cannot do, what are the like benefits it has. So in Azure Machine Learning, there are like all the components are like divided into three different categories. One is author, one is asset, third one is manage. So in the author, if you want to create a new machine learning model or train a new machine learning model, that falls here, where you can use a Jupyter Notebook for to write your own code and train the model. If you just want to use a visual tool, an automated machine learning model, where you will just upload the data and select, it will be a classification or regression model, and the model will be automatically trained. All those steps are automatically done. You will just get that trained model, then you will select automated model. But if you want to do a bit more detail than automated model, but less detail than like notebooks, as in a Jupyter notebook, then you will select Designer Studio, which is low code. This is no code and this is full code. So because we all hear about like no code, low code, full code, and Azure Machine Learning Studio is providing all three options. And other than that, if you want to write code in your own environment, in your own Visual Studio Code, you can also like do that one. I will also like talk about a bit later. But on that one, you will use Azure Machine Learning VM or compute. You will write your code in your own script in your local machine, but you will deploy the code in that on that VM and run it over there, so that even if you don't have any GPU, there is no issue. The second one is asset. On that asset, you can like upload your data set. You can manage your data set. You can like create different pipelines, experiments. That experiment works with different kind of like a script, automated machine learning designer. Everything under each of the task is one experiment. You can have your own pipeline where it can bring the data, process the data. You can do scheduling run of the machine learning training, so that you won't have to manually like write those script. It will be automatically invoked based on when you schedule it. All the models that you train will be registered here. If you register it, that's a part of the process. Every model that you deploy will be in the endpoint as an RESTful API endpoint. Then the manage section, you have the compute, you have the environment. On the compute, you have different kind of like training cluster, inferencing cluster. If you want to use a big GPU cluster, you will use that training cluster. For inferencing, you will use that one. You can select both CPU and GPU compute. You can also select ACI and AKS. ACI is Azure Container Instance, and AKS Azure Kubernetes cluster. So a service, which is if you deploy your model in a single container, it's ACI. If you deploy your model in a like a big cluster of multiple containers, that's AKS. All of them are actually managed. There's like a new feature in Azure Machine Learning, which is environments. So if you are designing a model in TensorFlow or PyTorch or scikit-learn, one of the big headache for data scientists or machine learning engineers is creating environment. Every time we are creating using like a new model or new algorithm, we need to create that new environment, deploy that model, like because those when you create those environment, it also downloads a lot of like libraries. It costs like takes a lot of space in your machine. That is a lot of time consuming work. So they have also like created like a section in environment where all the Docker container for PyTorch, for TensorFlow, for scikit-learn, XGBoost, LightGBM are already there with all the necessary modules. You just like click it, it will be done, and you can deploy your code or run your code on that Docker container. It's very easy. Then you have data source, which is like data store, which is data different type of like data sources. You have data labeling. So suppose if you have a lot of like images, but they're not annotated. Suppose you're doing a two-class classifier for a mountain and sea detection, but you have a lot of like mountain image, you have a lot of like sea, ocean image, but they're not classified or they're not annotated. On that one, you can use data labeling where you will select connect linked any kind of blob storage from there to data labeling tool. You can select there will be two class of classifier, mountain and ocean, and then you will create like a free tool where you can automatically just select different kind of like labels from that image, and it will be automatically stored, and you will get an Excel file mentioning which image name is following under which data label or which criteria. And other than that, the last one is the link service. If you have used any Synapse workspace, that falls under link service, where you can connect Synapse workspace with Azure Machine Learning and use the compute and all those automated machine learning and everything. So this is the high level overview of Azure Machine Learning component, where you will get a lot of question from all of them actually, author, asset, manage as well. Okay, when you create Azure Machine Learning or use Azure Machine Learning, you deploy your machine learning models in a situation where it's scalable. So as I have already said, you can have different kind of like data sources. Could be SQL, so could be Cosmos, could be some kind of like data lake, and you have the option to build and train machine learning models in Azure Automated Machine Learning. You can also use just the compute, write all the code in your local machine, and then just upload the script on a Docker container or a certain VM under Azure Machine Learning Compute to train the model, do all the debugging. You can containerize your model and deploy it as a Azure container instance to test your model, which is validation. If you are satisfied with the trained model, you can scale it with Azure Kubernetes Service, where there will be the same Docker container that you have used for a single test. You can deploy it as a 10, 15, 20 container. And the last one is monitor. You can monitor the model, how the model is performing, how it is handling drifting and everything. And along with all those things, Azure DevOps is integrated so that you can have CI/CD, model retraining, and everything. So one of the thing is when we always hear about like data ops, ML ops these days, which is a data and AI version of DevOps. So you can do all those like data ops and ML ops using Azure DevOps integration or Azure pipeline and DevOps. Okay, so how, from a conceptual point of view, how this custom model development and training works. So you have, as I said, you have your own model script in your local machine. You can take the script. It can use Keras, it can use TensorFlow, it can use PyTorch or anything. You just write code to connect with your Azure Machine Learning. You create use the Docker to create an target compute target, create a an environment, and deploy this same simple script on an Azure Machine Learning experiment container. And every time there's some changes and everything, or any kind of like log or any kind of like result or trained model, everything will be stored in Azure like blob storage. So that's how you are getting this full environment in Azure ML workspace, where you won't have to buy CPU or GPU or expensive compute. You won't have to do anything extra. Just have your subscription resource workspace. That's it. Okay, so now for the DP100, this exam. So you need to like know specific certain amount of like information. You need to know how to train your model, what kind of model you will select, how to deploy your model very high level. Mostly which algorithm to select, how AutoML works, how designer works. Today in our it's a 1 hour session. I'm not giving any demo of that one, all those like step by step model training, model deployment, because it's impossible to cover all those things. But that's why we have this AI 900. This is the first requisite, like a prerequisite of your passing DP100. You need to review this AI 900 exam so that you know how to train the model, you know how to deploy, which algorithm to choose, which classification, regression, time series, when to choose what, why you choose them, and how to train it, what is the result, how to download the model, and all those things. You have everything here. Just you need to like review it first. Within that AI 900, you will see different kind of like content like machine learning, anomaly detection, computer vision, natural language processing, conversational AI. But you don't need to like review everything for DP100. You just need to review machine learning content and some anomaly detection. Uh, that's it. And if you just review these two, which is like 30 minutes of the full video, you will be good to go for machine learning training point of view. Then we in the at DP100, you also have a certain position requirements regarding Azure machine learning model deployment, model monitoring, drifting. So as I said, model deployment has two options: Azure Container Instance (ACI) for a single model container, or AKS for like a scalable model deployment. So you need to know how to deploy the model. So there is another video we have done this year, January 21. So on that one, you will see how to take a model that you have already trained, how to download it, how to upload it, how to deploy it as an ACI, how to deploy it as an AKS. You also see that how to create Azure Compute instance or Azure Compute for different kind of training. You will find it on this video. You also see what is model monitoring, what are the types of model monitoring that exist, and how you can monitor models in Azure machine learning, and what is data drifting, how to do data drifting, and how to do uh, like add data drifting pipeline in Azure machine learning. So those options are also like there. You can just use go through this full video. You will have to go through the full video, 1 hour. Then you will have full idea of how to do it. So from that high level, as I said already, you will by going through these two videos, you will know how to use Azure Machine Learning Studio, how to train the model, which algorithm to use, which algorithm to choose, how to download the model, and also evaluation metrics, all of them. And the second one is, after going through this video, you will get to know AML model deployment process, AML compute, AML model monitoring, drifting, and AML best practices. So after reviewing these two, which will take, if you go for with like a 2x speed, 1 hour of you will have the full information that you need. And those two videos are actually done by Azure India, and was hosted by Azure India, and I was the author of all those videos. Okay, then the DP100 for the learning path, you need to review few certain things. One is creating machine learning models. You need to know some theories, some the practical part will be done by those two videos, and the theories I will cover it right now with those sample questions. So you will need to know how to create machine learning models, how to do ML modeling, how to build and operate ML solution, and also I missed it. It will be the last one would have been the uh, operationalize all the other aspect of a machine learning model. So the first, right after you review the Azure automated machine learning and all those things of those two videos, you also like need to practice few things. One is how very basic data science stuff, so which I'm not covering in this video, which is you need to review pandas library, numpy, scikit-learn, and matplot libraries. Pandas is for more like a tabular data processing. Numpy is also like a small data related operations. Scikit-learn, it has a lot of features are already there, data imputation, data cleaning, even modeling as well. Matplotlib is used for data visualization. So you can use Azure Machine Learning, just create a notebook as Jupyter Notebook and try for some data wrangling, statistical analysis, data visualization, imputation, data normalization, and handling clean missing values. I'm not covering those components in this video, but this is one of the first thing that you should go through. Once you go through, then you will also need to review this kind of thing, what is this kind of machine learning model, like regression, classification, clustering, and deep learning. So as I have already talked about those models in the category 1 data, which is regression is prediction of single value, classification is classifying between binary two class or multi-class values. Clustering is unsupervised machine learning approach, which if your data is not annotated, if you just load it, run clustering algorithm, and you can automatically find out different clusters, which values belongs to which cluster. One of the very common algorithm is k-means clustering. You will see a lot of example in this Azure machine learning side as well, in the designer side, where you can directly use k-means clustering algorithm by dragging and dropping in your designer span. And the last one is deep learning models. So deep learning is a big topic, which is you will get some questions regarding convolutional neural network, like shape detection or shape detection classifier. You will get a use case where if you have if you design a three-class classifier of a triangle shape, uh, circular shape or a square shape, how would you do that? What are the steps in the convolution? How would you do max pooling, mean pooling? What is dropout? What are the activation function or learning rate that you need to use? So all those things. What kind of configuration you need to choose for hidden layer? What kind of configuration you need to choose for the final layer? So all those things will be under the deep learning. So you can expect very basic questions and answers from deep learning like a model section, but I will also show how to do it. So additional optional resource right after giving reviewing the AI 900 and AI 102 AI 900 and AI that Azure machine learning deployment monitoring drifting section. There are some additional resources I will recommend you. So I will recommend you to review this automated machine learning using Azure ML, this video, which is also like we did it with Global AI Bootcamp of 2019 with Azure-INDIA. So this will give you the more idea about how to use automated machine learning. So which is a part of DP100. And right after that one, if you are interested to learn more about this DP100 or how deep learning works or CNN works, I have also did one video few years ago, like maybe 3 to 4 years ago, yeah, in 2018. So on convolutional neural network with Azure Data Science Virtual Machine. So you can review this video, just more like the slide to get more idea about what is CNN, how what are the components, what is a different kind of learning rate, activation function, all those things. So that will be another additional learning resource that you need to go through. Okay, once you train all the model, go through those videos, you will also get some kind of get questions regarding model evaluation. So this is one of the ROC curve, confliction matrix, sorry. On the confliction matrix, which is a very common way of identifying which is it's a good model or bad model. So every time you can see this is the predicted 0 and 1. It's a two-class classifier. This is the actual 0 and 1. If you predict 0 and actual is 0, which means it's true. If you predict 0 and the actual is 1, which is it's like a negative. Um, so you need to know what is true positive, true negative, false positive, false negative. When the model predicts 0 and the actual value is 0, it is considered as true negative. When the model predicts 1 and the actual value is 1, it is true positive. So which is bottom right, this one. And when the model predicts 0, but the actual value is 1, which is this one, it's called false negative. When the model predicts 1 and actual level is 0, it is considered as like a false positive, which is at top right. So you will get this kind of like very simple, tricky questions. And also you will get some questions regarding what is accuracy, recall, and precision. So when you add true positive, true negative, and divide it by all of them, true positive, true negative, false positive, and false negative, you will get the accuracy, which is how many were actually correct, which is the prediction. And the recall is you will, if you just take the true positive, which is this one 1 1, and divide it by the true like positive and true negative, false negative, which is considered as of all the cases that are positive. So how many did the model identify correctly out of 1 by 1? The precision is true positive divided by true positive plus false positive. So of all the cases that the model predicted to be positive, how many are actually positive? So these three are very important, like three terms in data science to evaluate more your model: accuracy, recall, and precision. These three, you need to know that. Okay, so these are the like a high level information that you will get. What kind of like machine learning model, like regression classification, time series is using, how to evaluate, very basic way of evaluation of an evaluation terms. So right after that, you will get some like again, we will ask some question whether did you understand what we talked about or not. So okay, the first test one will be regarding the NumPy and everything. I'm expecting if you haven't used NumPy or pandas, you won't be able to answer this question. But if you can, just let me know. Suppose you have a NumPy array with the shape of 2 by 20. What does this tell you about the elements in the array? There are like three options. Uh, if you know the answer, just let me know. The array is two-dimensional, consists of two arrays, each with 20 elements. The array contains two elements with the value of 2 and 20. Uh, the array contains 20 elements, all with the value 2. So the reason why I'm showing it, if you haven't covered NumPy or pandas, this is the motivation that you should cover. So this simple shape 220, the simple notion represents the array is two-dimensional, contains of two arrays, or each with 20 elements. So you need to like know basic operations of NumPy and basic operations on pandas. So which is I'm not covering in this video. Then you will also like get a lot of like questions regarding like scikit-learn and also like Jupyter Note, like some question regarding Jupyter Notebook. So some of the question could be like this: you are using scikit-learn to train a regression model from a data set of sales data. So it's a regression, which is a numerical prediction. You want to be able to evaluate the model to ensure it will predict accurately with new data. What should you do? Okay, use all of the data to train the model, then use all of the data to evaluate. No, you cannot use all the same data for train and evaluation. It needs to be separate. Usually the rule of thumb is you always, if you have a data set, you need to like split it between 70% as train, 30% as evaluate, like validation and testing set. Okay, the second one is train the model using only the feature columns and then evaluate it using only the label column. And the third one is split the data randomly into two subsets, use one subset to train and another subset to evaluate. So can anyone answer which one it would be? 1, 2, 3. Okay, it will be number 3. As I just said, Every time, the rule of thumb, when you train a model, you need to select 70% of the data as a training data, 15% of the data as validation, 15% data as a testing. So here you can also like split, that's why we say it, randomly to two subsets, one for train and one for evaluation. So you will get this kind of basic data science questions a lot. So, okay, third question could be, I hope you guys will be able to answer it as I have covered this topic during my last conversation, this conversation. You plan to use scikit-learn to train a model that predict credit card fraud. Okay, the model must predict a value of 0 for loan applicants that should be automatically approved and 1 for applicants that there is a like a risk of default that you requires human consideration. What kind of model you will require? So it is predicting based on all the data, the outcome will be 0 or 1. So is it a binary classification, multi-class classification, or linear regression? What kind of model it is? Can anyone answer? One.
Binary. It's binary.
Binary. Yes, it is a binary classification because you are predicting between 0 and 1. So if you were predicting between 0, 1, 2, 3, then it was a multi-class classification. Okay, I have also like talked about this specific topic. So in k-means clustering is an example of which kind of machine learning algorithm. So we know that there are like three types of machine learning algorithms. One is supervised machine learning, one is unsupervised, one is reinforcement. In supervised, all the data are already annotated. In unsupervised, it's not annotated. Reinforcement, it's not. So the model learns from the data. So as you said, everyone is answering two. It is unsupervised. So that's true. The fifth one is you're creating a deep neural network to train a classification model that predicts to which of three classes an observation belongs based on 10 numeric features. Which of the following statement is true of the network architecture? Okay, so so if I like make the question a bit easier, you are designing a neural network or deep neural network where it's taking 10 values as an input and output is one of the three. Is it like 0, 1, or 2, something like that, which is three classes. So which one is true? The input layer should contain three nodes, the network should contain three hidden layers, or the output layer should contain three nodes. Which one? So it is a three classes. So it should be at the end, three class classifier. So it needs to have three nodes at the end. So the input is 10. The hidden layer can have everything. They can have like one hidden layer, two hidden layer, three. But the output, if you have three classes, it will be three. If you have 10 classes, it will be 10. If you have two classes, it will be two. So that's how it is. Perfect. A lot of people answered it right. So which is good. So okay, this kind of questions you will be asked regarding on the first section of DP100, like what kind of algorithm they should choose, what will be the input, what will be the output, like what kind of like type of machine learning model, regression classification it should choose, something like that. Then the second section will have questions regarding visual tool. There are like two types of in the visual tool we have already discussed. One is automated machine learning. Second one is Azure Machine Learning Designer. So this is automated machine learning. So what is it? You just upload your data set. You select, is it a classification, regression, or time series, and then you select press run. You also select the like compute. Is it going to run on a big GPU cluster or a simple small one node cluster? And all those other things, the machine learning training, the feature, the parameter tuning, everything is handled by the automated machine learning. And at the end of all the training, you get results like 50% training score, 76, 53, 95. And you also get a leaderboard like that. The rank 1 model, light GBM with 95% accuracy, rank 2, 76, rank 3 is 53. So it makes your life very easy. The hyperparameter tuning is handled by it. The model training is handled by it. All which algorithm to use is handled by it. So all you do is upload the data. If you want to look at the data as a with different graphs, it is also so automatically done as a data exploration section. You just select your model, select like classification, regression, or time series. If you're predicting a number, regression, classes, classification, or a time related stuff, it's a time series, and that's it. And you can also ask, okay, how do I know this model is good model or bad model? This automated machine learning also gives us a global importance, local importance related information. So the model is also explained through different graphs that it's a good model or bad model. And after doing the training, you can also deploy the model as a Azure Container Instance training environment. Okay, and the second part is Azure machine learning, Azure ML designer section. So, which is not, as I said, it is a low code section. So, does it mean you will have to write code? No. So, which means, so it looks something like this on the right section, where you drag and drop based on you will search it. You will have your data set, all those like statistical function, compute with like a function, anomaly, algorithm, and everything. All you do is drag and drop each and every component and connect them. So you drag and drop your data set, you select which column to use, you select add clean missing data for data processing. As we said, in machine learning, you need to divide your data into like two parts. One is training, one is testing. You select it here, training data, and another one is testing. You select the algorithm, which is here we selected linear regression, and we connected as a evaluate and score model. So all those things, you can also add custom code like R language or Python language and do some small coding as well. That's why I called it low code. So this is another section thing where you will get some questions regarding ML designer, what kind of modeling you can do, regression, classification, clustering. You can create this kind of, we call it pipeline. You can create and run this kind of like training pipeline. You also like need to select upload the data set by yourself from your local compute, or you can connect that blob storage or something like that. You can create compute that it will run on a like a single like core 2 gig RAM machine or something like that. You can also like after doing the training, if you are satisfied, you can deploy the model as a web service so that you can do different kind of like RESTful approach of testing your model. And as we have already talked about a bit regarding accuracy, precision, recall, and F1 score, you will also like get all those numbers automatically created and generated by the Azure machine learning through this tool. And one of the thing I didn't talk, F1 score, which is also very important in evaluation, which combines everything together, accuracy, like precision and recall, to know how good or bad this model is. So in this section, mostly automated machine learning, and you will get information regarding machine learning designer. Okay, so let's see some of the questions, how it will look like, because again, like as we said, it will take a 1 week of full training to cover all those like section of DP100. So we are just like giving the high level information, how to prepare yourself for the DP100. So one of the question is you are using Azure Machine Learning Designer to create a training pipeline for a binary classification model. You have added a dataset containing features and labels, a 2-class decision forest module, and a train module, all those components that we have already talked about. You plan to use core model and evaluate model to test the train model with a subset of the data set that was not used for training. Okay, which is good. Which additional kind of module should you use? You will use join data, split data, select columns in dataset. Here, after loading the data, we have split the data into train, and then there is like a section for the test. So here, what will be the answer? Join, split, or something else? Two, split data. That's true. You need to like split data into two sections, like as a for training and testing. Then you are using Azure Machine Learning Designer to create a training pipeline for a classification model. What must you do before deploying the model as a service? Create an inference pipeline from the training, add an evaluation module to the training pipeline, clone the training pipeline with a different name. So What is happening? So here, before the deployment, you need to evaluate it is a good model or bad model because you are doing the training. So you should not add inference. You should add this one. Oh, sorry, I was doing the mistake. So once you do the training, which is already done, so you will deploy. So deployment is like put it as a web service that we talked. So which is this one. And before the inferencing, to trace test the model, which is whether it's a good model or bad model, you need to evaluate the model, which is section 2. So create an inference pipeline from the training pipeline, which is also like automatically gets created. If you take a look at the automated machine learning like video that it is showed over there. Okay, the next one is an automated dealership wants to use historical car sales data to train a machine learning model. Okay, the model should predict the price of a pre-owned car based on its make, model, engine size, and everything. So which means you will have to train a model based on all those like 4 values. What kind of machine learning models should the dealership use in automated machine learning to create it? Classification, regression, time series. So it is predicting a value of a price of a car. So it is a when we predict a value, it is a classification model or regression model. Which one? Any answer? One or two or three? Okay, it is a regression model because you're predicting a value. So you guys will get this kind of questions as well. Sometimes it's big, it's hard to read, and it could be a bit tricky. Then a bank wants to use historical loan payment, a loan repayment record to categorize loan applicants as a low risk or high risk based on the characteristics like the loan amount, the income of the borrower, and the loan period. What kind of machine learning model should the bank use to create in automated machine learning? Is it like a classification, regression, time series? Classification, true, because you want to see it's like a low risk, high risk. That's a two-class classifier. And now the third part, which is build and operate machine learning model. So now the question is, what kind of like data sources the machine learning, this Azure machine learning supports? So there are like two types in AML data section. One is data store, and second one is data set. On the data store, it is data sources. So data source like Azure storage, blob storage, Azure data lake store, Azure SQL database, Azure Databricks file system, DBFS. These are the data sources as a data store is supported in Azure Machine Learning. All you need to do is you need to link those store like sources with your as a data store in your Azure Machine Learning and done. And you can also ask what kind of data set is it supports. It supports both tabular, structured, and unstructured data set. Tabular for structured and files unstructured is for file system. So this is this tabular is used for like classification, regression, time series, and this file system is used for image classification or CNN based training. So these are the only two types of like data set that you can select, and that's all you need to train your model. As we said, it only requires category 1 data, which is tabular, and category 3, which is image processing. But category 2, which is all the audio or like natural language processing, is out of syllabus for this DP100. So when you train your model, if you train a model today and you are like satisfied that this is the model that you will use for future purpose or like every day or in production, and the model is something like a recommendation or time series forecasting, like what will be the predicted whether tomorrow it will rain or not, what will be the predicted temperature tomorrow, those kind of models. So in that case, for these kind of models, you need new data every day. So how, like once you train the model, how are you going to retrain the model? Are you going to do it manually? Are like you will need some kind of like pipelining or scheduling. So there is a option called Azure Pipeline where you can trigger different kind of like data processing part you get different kind of like machine learning training. If you have already have script that is already used for one training, you can use that one for retraining your model every day as a scheduling approach, so that you won't have to do those manual things by yourself. You will just use that one. When you are doing the training of your model parameter model, you will find situation where you need to use different kind of like parameter. Suppose there are ABC, like example, three parameter. The values of those parameter could be discrete, or sometimes could be as a like continuous values. So how are you going to, and you will have to run hundreds of AI training to find out the best parameter or best combination of parameter for your model. So you can also like do parameter tuning for Azure Machine Learning to select the best model, but like using automated machine learning or designer or from your script. And you can do the same process for best algorithm selection as your machine learning automated machine learning does it for you. Or you can use designer section to select linear regression, all the other types of like regression model, and get manually which algorithm gives you the best result and select it by yourself. For model monitoring, there are different kind of like log storing, log querying, log analytics, health, how many requests and response you have made, and also there is a data drifting option. So in one of the video, as your model deployment, monitoring, and data drifting, I have talked in details about those section, and you will get some questions regarding that. Just review that one. You will be good to go. And the last one is model explainer. So every time you train a model, you need to identify it's a good model or bad model and why this model is giving this result. So if you use 10 features to train a model, after doing the model training, you will also get two types of graphs in the explainer section in Azure Machine Learning, which is local importance metrics and global importance metrics. In local importance metrics, it indicates the influence of features on a specific prediction. So if you have a prediction, tomorrow's temperature for this is 10 degrees Celsius, example, for this specific prediction, which like feature yesterday's temperature, the location, or something else, like which are the most impactful, these are considered as a local importance indicates. And the if you want to find out for all the prediction that your model is making, which are the specific features or columns are the most impactful, that is considered as global importance of like factor, which is global importance gives an overall indication of feature importance. So why you need it? To tell this is the genuine model and these are the like features that are impacting to like behind every single decision. So that's why you need it. So you will get information from my model deployment and training section as well, like more how it looks like, how to do it, how to use it. Then there is like Azure Machine Learning SDK. You will get some questions regarding that. So on the right bottom like image, you can see there is Microsoft Azure. You have subscription like for your organization. Then you create a resource group under each subscription. Under each resource group, you create workspace. Here we are using Azure Machine Learning Workspace. Every time we create Azure Machine Learning Workspace, you get compute, you get notebook, you get pipeline, data, experiment on module. These kind of like features of Azure within this workspace. At the same time, you also automatically create, it also automatically creates a storage account for you, application inside to see the health or monitor all the request and response. You also get like a key vault to store all the key, secondary, primary key, and also container registry if you are on like a registering container with your workspace. And with Azure Machine Learning, you get the options like scalable on-demand compute, all sorts of like CPU, GPU. You get all the data storage activities or connectivity. You get ML workflow orchestration as a pipeline. You get model registration. Every time you train a model, you need to register it to for model registration and management to use it by other experiments. You need to you have metrics and monitoring as a data drift, key vault, like insight and all those things, and deployment for model like RESTful API. So you're getting all those things under Azure Machine Learning Workspace. And you also get the SDK, machine learning SDK, which is giving you everything. So how to use it? So you can just like do it's a PEEP installable Azure ML SDK from your local machine. All you need to do is follow this hierarchy: subscription, resource group, and workspace name. You need to follow this approach to connect your local machine with your like Azure ML through this SDK. You can run machine learning operations from your preferred development environment, like local machine. You can write all these script in your local machine, and just when it's time to train it or run it, the script will be uploaded in Azure ML Compute and run it there under Azure ML. You can automate asset creation and configuration to make it repeatable. If you use this Azure ML SDK, the same script could be used in multiple cases, multiple like projects as a infrastructure as a code. You have that option. You can ensure consistency for resources that must be replicated in multiple environments. Just like I said, development, test, production. You can have within an Azure ML, you can have three types of environment using the same script, and also all those CI/CD pipelines and everything, DevOps, data ops, ML ops. You can replicate them, like implement them using Azure ML SDK. Then there is another big topic that you will find is compute. So every time you have some script, you want to run that script in under Azure ML, you need to select a compute target, which is this box. And on that compute target, you can use a Docker container to create the exact environment that you need, and then deploy your model or run your model on that one. So this is the approach. So in the AML compute, you will see options like local compute, compute cluster, attached compute. Local compute is the single machine that you are using. Compute cluster is a big GPU cluster that you can provision for multi-node model training. And attached compute could be like external compute like Databricks. Code can be developed and tested on local or low cost compute, and then move to a more scalable compute for production workload. You can do that one for like cost purpose, and you can run individual processes on the compute target that best fits its need. If you need GPU, you can use GPU. If you need CPU for lower cost, you can also use that one. You have that like flexibility. And that's how machine learning production section looks like in Azure ML. So you have this pipeline, as we have already talked about. You create the pipeline, you push the code to train the model. Using the pipeline, you can train the model, evaluate the model. Once you are satisfied, you register your model. This is the first part. Register your model in AML model management. Once you register your model, you can take the model and consider it as like a staging or QA environment to package the model in an Docker image. You can deploy the model as an Azure container instance and test the model as a web service. And when you're doing it, you can also have Azure App Insight to health or like check the health or monitoring the model, how many requests you have made, is a good request, or what were the response of all the requests. And if you're satisfied with the performance, you push it to deploy it as a AKS, as a Kubernetes service, like a web service, like a cluster, where you can have multiple replica of the same container that is registered here, and you can deploy it as well using Azure pipeline. So it is data driven, it's schedule driven, and it's metrics driven. And when you are doing the model deployment, there's some steps you need to follow. You need to register your model. You need to define inference configuration, like which script will be the first entry point of this like container, and how the environment will be. What are the like the Docker file or YAML file. You also need to select different kind of resources like CPU, memory, is it SCI or AKS? And when you deploy it, it will be deployed as an inferencing as a RESTful endpoint. And to use that RESTful endpoint, there are some authentication options that are also available, which is primary, secondary key, or like some kind of like 10 minutes token that you can also use. and it is for single like a request and response. If you want to use it for batch, you have option for batch inferencing with parallel run setup. The same approach, you just add the parallel run setup. Okay, these are all the like information that you need to know regarding the Azure machine learning or model operation or running. So now some questions, the last part of all the like sample questions we will ask now, which is the following descriptions accurately describes Azure machine learning. So it is a Python library that you can use as an alternative to common machine learning framework like blah blah those scikit-learn PyTorch. It is a cloud-based platform for operating machine learning solutions at a scale, or an application for Microsoft Windows that enables you to create ML model by using blah blah drag and drop. So which one is Azure machine learning? Like which specific statement goes describes the most? Anyone can answer? One, two, or three? Okay, the answer is two, which is a cloud-based platform. So it is a cloud-based platform because you're not. It's not a library. It has an SDK, and it's not like a application. You have run an experiment to train a model. You want the model to be stored in the workspace. Okay, you have already trained it, and now you want to store it and available to other experiments and publish it. What you should do after doing the training, you need to what is this step is registering the model in the workspace, save the model in your like compute instance, or save the experiment script as a notebook. So you have already trained it, you have the binary file, so you need to register it as we have already said. Then a data store contains a CSV file of structured data, which is tabular, that you want to use as a pandas data frame. You want to load the data, and then you want to use it as a pandas data frame for data processing. Which kind of object you should create to make it easy to do this? Is it like a data store, tabular, or file data set? Oh, I just clicked. Okay, it is like a tabular data set that you need to use. Then the next one is you must create a compute target for training experiments that require a graphical processing unit, which is GPU. Your training needs a GPU. It could be a PyTorch or TensorFlow based model. You want to be able to scale the compute so the multiple nodes are started automatically as required. Which kind of compute target should you use? So there is like compute instance, compute cluster, inference cluster. It is for something small. It is for something small. The number two is compute cluster for something big, which is GPU. A lot of people answer two. You have trained a model using Python SDK for Azure Machine Learning. You want to deploy the model as a containerized real-time service with high scalability and security. So you want to scale the model and you want to have full security, like authentication and everything. What kind of compute should you create to host the service? Is it like Azure AKS inferencing, Azure ACI with GPU, or a training cluster with multiple node? It is AKS because AKS has the scalability and also the GPU, like the authentication for security. Okay, the last question. You have trained a classification model and you want to quantify the influence of each feature on a specific individual prediction. So it is an individual prediction. What should you examine? It's like global feature importance, local, or recall. I got answer local. Yes, local feature importance. So these are the type of questions that you will get to pass DP100. Uh, as the topic of DP100 is very big and it is massive, you need to like go through additional resources. We have like AI 900, the video that I've talked about, like AML model deployment, like drifting, monitoring that video. And also, if you want to go through other two optional videos, you can also go through them as well. And you need to read the DP100 training resource official by Microsoft. And there are some like lab tutorial by this one. So once you go those four videos plus go through these, follow this learning process pattern, you will, I believe, pass DP100 easily. We are already running, we have already like covered more than 1 hour. So that's it of my today's session. Thank you. And if you have any question, let me know on Twitter or LinkedIn. Feel free to connect with me. And thank you. I hope I have all the best wishes for you so that you can pass DP100 easily. Thank you.